Hey everybody, this is John from DK MCAT Prep. The video that I'll be doing for you today will give you an overview of some common structural representations that you're likely to see on the organic chemistry portion of your MCAT. Just to keep things simple, I'll be representing the same molecule with all the structures that I'm doing today. The formula for this molecule is going to be C3H8 O, or 1-propanol, but we'll get to the naming of that molecule in a later video. First, we have the dash formula. This is a very basic formula that illustrates the molecule in a two-dimensional manner. Now this structure just simply shows all the atoms present and the bonds between them. The next one that we're going to look at here is the condensed formula. This shows all the central atoms in the molecule followed by the atoms that they're bonded to. But one thing you really have to watch out for with this model is to not get mistaken between atoms that are put adjacent to each other but actually don't bond. For instance, the H2 here and the O here, though they're listed together in this formula, they don't actually bond, which you can see with the most basic of structural representations up here in the dash structure. The next structure that we're going to look at here is the bond line formula. Now this is probably going to be the most common structure that you see on your MCAT. And in this structure, all ends and line intersections are implied carbons. And on each of these carbons, unless otherwise specified, you're expected to see the maximum amount of hydrogens. So each carbon, unless shown otherwise, will be saturated. Next we have the Fischer projection. Now this is the first projection that we're doing, which is actually going to show the molecule in a three-dimensional structure. To me, this one always looks a lot like a dash formula, just on its side. But some of the key notes that you need to see here in the Fischer projection are that the non-terminal carbons, though they aren't expressed with letters, do exist. And you can see those here at the line intersections. Those are the non-terminal carbons. And another thing that you should note is that in this model, in order to get a three-dimensional view of things, all horizontal lines, such as this one here, are supposed to be viewed as if they're coming out of the page towards you. And in contrast to that, we have all the vertical lines, which are assumed to be going back into the page. Looking at the molecule in this way, you're able to see a three-dimensional structure forming around each of these non-terminal carbons. And this allows you to get a view of the rotation and the orientation of each of these substituent groups on those carbons. So you can get a good view of the three-dimensional structure, or stereometry of the molecule. But that's something we'll cover in a later video as well. Next we have the Newman projection. This projection shows basically an end-on view of a carbon-carbon bond within a molecule. So the way that you focus on this bond in this case is the intersection of these three lines, as shown here, illustrates the front carbon in a bond, whereas the more distant carbon is shown as this circle behind it. Now this becomes very useful when analyzing the rotational stability of a molecule, as you can see how each of these groups will rotate in relation to the focused bond. Next is the dash line wedge formula. Some key notes that you need to remember on this formula are that these dashed wedges should be read as if it's illustrating a bond going back into the page, whereas the solid wedges, such as this one, should be viewed as if it's something coming out of the page at you. And these straight lines, as shown between each of the carbon-carbon bonds here, and the carbon to OH bond here should be viewed as if they're in the plane of the page. And lastly, we have the ball and stick model. This model shows a three-dimensional view of the molecule in which the atomic radii of each atom and the relative bond lengths are drawn to scale. This becomes very useful because it gives a clear view of both the bond angles present in the molecule and the molecular structure. Well, I think that's all for this lesson. But if you have any questions, comments, or suggestions for later videos, just post them in the comments below. Thank you.